Okay, that should have been enough time. What you should have learned on Friday was the first thing that you need to look at is you need to look at the degree. The degree is going to tell you one of two things. It's either going to tell you if it is odd. If the degree is odd, then the function is going to go in two different directions. Meaning, it's either going to go that way, or it's going to go that way. If it's even, they're going to go in the same direction. So, like that, or like that. Okay. Again, that is from Friday. Then the second thing that you have to look at is you have to look at the lead coefficient. If the lead coefficient is positive, the right side goes up. If the lead coefficient is negative, the right side goes down. And then your left side is dependent upon if they're going in the same direction or if they're going in different directions. Okay? So, looking at warm-up number 1, what is the degree? What is the degree? Actual physical degree. What is it? It's what, Stephanie? It's what? You just said it. I watched your mouth move and sound come out. What is it? 4. It's 4. And is that odd or even? That's even. So the degree is actually 4, which is even. So what does that tell me?
Same direction.
That means that it's going to be going in the same direction. Either both sides are going to be going up, or both sides are going to be going down. Okay? Second look. What's the lead coefficient? It's positive 7, so that's positive. So that means that my right side is going up, and because it's an even degree, that means my left side is also going up because they have to go in the same direction. Correct? So both of these then are going to positive infinity because it's going in the same direction on both sides. Okay? Number 2, degree. The degree is 5, so that is odd. So that tells me what? Going in opposite directions. Okay? Lead coefficient. That's negative, right? So that tells me that the right side is going down. So as x is going to positive infinity, the right side of my graph is going to negative infinity. Which means that the other way, as x is going to negative infinity, because they have to go in different directions, my function is going to positive infinity. Okay? Now, today what we're going to be doing is we are going to be investigating linear functions quadratic functions, cubic functions, quartic functions, quintic functions, whatever you want to call a function to the 6th power, okay, etc. All right? And so it's going to be a lot of group work today, okay? And then I'm going to stop you along the way, and then we're going to make sure that we're all on the same page. With me? Okay? So we're going to go through the first one together. Okay? So, group exploration. The possible shapes of various degrees of polynomial functions are shown below. So the first one is linear functions. What's an example here of a linear function? Give me an example of a linear function.
2x plus 4.
2x plus 4. Could I go f of x here? Sure. F of x equals 2x plus 4. Looking at that, what is the degree of that linear function?
1.
1. What's the degree of all linear functions? 1. Okay. Degree always 1. Okay. Is 1 odd or even? Odd. That is an odd function. Okay. So, that tells me that the sides of our graph are going in opposite directions, correct? So they're either going to look where they're going, it's going up and to the right and down and to the left, or vice versa. So those are the two possibilities that I can have for a linear function. Okay? I can't have a vertical because that's not a function, and I can't have a horizontal because that's a constant function. Okay? So those are my only choices for a linear function. Okay? So, if I took, now I gotta set this up here, if I took a line, and I called it, now you're going to use your pencil for this, okay? So if I took this line and I slid it up and down along that graph, either one of them, okay, this line here is going to represent the x-axis. And why is the x-axis important to us when we're dealing with functions?
Because that represents the x equals 0.
So that represents where the x is equal to 0, right? Which means the x-intercepts, which is the solutions, answers, zeros, factors, all that fun stuff that we've been talking about, right? Okay? So no matter where I go on that function, how many real zeros exist? 1. It's only ever crossing in one, or it's only ever touching in one spot, correct? Right? Okay? So that tells me that I can only ever have 1 0 in that. Now, knowing what you know about algebra, how many total possible zeros can a linear function have? Why 1?
It crosses the x-intercept.
But why does it only cross the x-intercept, or why does it cross the x-axis one time?
It's a straight line.
Because it has a degree of 1. The degree is also the maximum amount of zeros that a function has. Okay? So, how many real zeros exist for a linear function? 1. How many possible zeros? 1. So, can there ever be an imaginary zero in a line? No. There cannot be an imaginary zero in a line because the function must cross the x-axis. With me? Okay. Again, for your x-axis, here I was able to use a line. For you, the best thing that you're going to do is you're going to use a pencil. Okay? Use your pencil. So then you're not drawing and erasing and drawing and erasing and drawing and erasing. Just slide your pencil where it needs to be. Okay? All right. You and a shoulder partner, I'm going to give you the rest of the time to work now. We'll stop you, we'll come back, and we'll do quadratics, then we'll go again, we'll come back, we'll do cubics, then we'll go again, and so on and so forth until we get done. All right, so we're spot checking now. Okay, so let's do cubics. Or excuse me, not cubics. Quadratics. Okay, give me an example of a quadratic function.
X squared plus 4.
F of x equals x squared plus whatever, right?
Yeah.
Okay, right? That's a quadratic function.
Number of the day.
Paying attention to me right now, or are you gonna just keep having a grand old time? You sure? Okay. So what's the degree then, Colin?
2.
2, because it's the biggest exponent. Okay. Is that odd or even? That's even. So what does that tell me?
They're both going to go the same.
Both going to go in the same direction, right? Okay. Both going to go in the same direction. So the smallest number of real zeros that could exist. 0. Let me get my line on there. Oops. Oops. Did one too many. That one can be deleted. This one can be extended out. Fantastic. There we go. So if I go right there, it never crosses. If I'm looking just at this one right here, if I'm looking at that one, it never crosses my x-axis. Correct? So that's 0 real zeros. Right? How many total zeros must I have? 2, because my degree is 2. So if I have to have 2 zeros, and 0 of them are real, that means that 2 of them are imaginary. Okay? What's the biggest number of real zeros that I could have? 2. Again, if I'm looking at the red one, slide it up there, crosses in 2 spots. Okay? So if I have 2 real ones, and I can only have 2 total ones, that means that I have how many imaginaries? 0 imaginaries. Okay? Now my question is this. Is there any other possible number of real zeros?
Yes.
What?
1.
1. I could have 1 real zero. If I have 1 real zero, how many imaginary zeros would I have?
1.
No.
0. 2.
Imaginaries have to come in pairs.
2. Okay.
I'd have 0 imaginaries. Explain to me when I have 1 real zero and 0 imaginary zeros. Which point? The vertex is on the x-axis. Does anybody remember what we call it when the vertex is on the x-axis? The double root. Yep. Okay. So that one is a double. So we can have 1 real and 0 imaginary. But that 1 real counts as 2, so I still have my 2 zeros. Okay? With me? Continue on with cubics and quartics and quintics and all that fun stuff. All right, let's talk cubic functions. We should be able to burn through this one. All right, so what's the degree? I'll give you an example of a cubic function. F of x equals x cubed. That's a cubic function. What's the degree? 3. Is that odd or even? That is odd. Okay, that tells me what? They're going in different directions. So I have to have at least 1, 0, right? Okay, so the smallest number of real zeros that would exist would be 1. How many total zeros must I have? 3. So if one of them gets taken up by the fact that it's a real zero, that leaves me with 2 imaginaries. Okay? What's the biggest number of real zeros that I could have? 3. If I have 3 reals, and I can only have 3 total, that leaves me with 0 imaginaries. Okay? Can I have, so I've got, can I have 0 zeros? No, because they're going in opposite directions, right? So I have to have at least 1. So can I have 2 real zeros? Can I have 2 reals? If I have 2 reals, can I have 1 imaginary? No, because they have to come in pairs, so it would be a 2 real, 0 imaginary case. Can I have that?
Yes.
How? If one of them is a double. So here is my cubic function, right? And then here comes my x-axis. Oops. Right there. Okay? One of them is a double root. Okay? Can we whip through cortex right away too, or do we need a little more time? Let's do it. Okay? Quartic function, what's the degree? 4. That means it's even, right? Okay? Smallest number of real zeros that could exist? 0, right? Because if I'm looking at, we'll take this middle one here, or the second one in. So here is my x-axis. Never crosses, right? So that means 0. How many total zeros must I have? 4. If I need 4 zeros, none of them are real, that leaves me with 4 imaginaries. Okay? Go the other way. Biggest, most zeros I can have. 4, could all 4 of them be real? Yes, if all 4 of them are real, then I have 0 imaginaries. Okay? Could I have 2 and 2? Yes, I could have 2 and 2. Could I have 1 real and how many imaginaries? 2. Can I have that? Yep. Could I have 3 real? How many, if I have 3 real, how many imaginaries? 0 imaginaries. Okay? So that would look like, so 2 reals and 2 imaginaries would look like, there's that, there's that. There's 2 reals. Oh, nope, that's 1 real and 1 imaginary. One too high. Whoa, whoa, whoa. There's that one. Okay. 2 reals and 2 imaginaries. There's my quartic. There's my x-axis. 3 reals. No imaginaries. Hit it. Hit it. Hit it! Right there. With me? Okay. Your job tonight is to finish off that packet so that we can have it be done by tomorrow and we can move on.